If you could remove every star, every planet, and every gas cloud from space, you would find that the mass of the universe would remain virtually unchanged. Have you ever looked up at the night sky, truly looked, past the glow of streetlights and the haze of the city, and felt a profound, unnerving sense of being alone? You see the sprinkle of stars, a faint, milky smear that is our own galaxy, and you know, intellectually, that you are looking at hundreds of billions of suns. Each one is a potential campfire for another world, another story. And yet, the overwhelming feeling is not one of a crowded neighborhood, but of an empty, silent auditorium. The silence from that cosmic expanse is so deep, so absolute, it feels like a presence in itself. If you were to be cast out there, right now, into that perfect, cold vacuum, the sheer scale of the solitude would likely shatter your mind long before the lack of oxygen stopped your heart. You almost certainly wouldn't survive the realization. If that thought sends a curious shiver down your spine, stick around. Find a comfortable spot, dim the lights. Like, comment, and subscribe, because we're about to lean in close and listen to that silence together. We're going to try and understand what it might be telling us. You're drifting now, not in a ship, but in your mind's eye. Let the walls around you dissolve. The ceiling peels away to reveal that velvet blackness, pricked with those impossibly distant points of light. Feel the gentle tug of Earth's gravity, a comforting anchor in an ocean of infinity. You are on a tiny, fragile lifeboat, teeming with noise and life, floating through a cosmos that, by all accounts, should be just as noisy, but isn't. This is the heart of a question that has haunted scientists, philosophers, and stargazers for decades. It's a simple question, first uttered during a casual lunch conversation in the summer of 1950 by the brilliant physicist Enrico Fermi. Amidst talk of flying saucers and alien visitors, he let a few words hang in the air that would resonate for generations to come. But where is everybody? It sounds almost comically simple, doesn't it? Like a host wondering why no one has shown up to his party. But when you unpack the luggage that comes with that question, the implications become staggering. You have to start with the sheer, mind-numbing scale of it all. Your home, the Milky Way galaxy, is a sprawling, spiral city of stars. The current estimates, and they are just that, estimates, hover between 100 billion and 400 billion stars. Let's just pick a number for sanity's sake. Let's say 200 billion. Now, try to hold that number in your head. If you were to count one star every second, without sleeping, eating, or taking a bathroom break, it would take you over 6,300 years to count them all. And that's just our galaxy, our local neighborhood. Through the lenses of powerful telescopes like the Hubble and the James Webb, we can now see that the universe is stuffed with other galaxies. There are perhaps 2 trillion of them in the observable universe. 2 trillion galaxies, each with hundreds of billions of its own stars. The number of potential suns becomes so large that our language, our minds, simply fail to grasp it. It's like trying to describe the ocean by counting every single drop of water. It's functionally infinite from our perspective. Now, let's bring it back home. Our sun is a pretty average, stable star. Nothing particularly special about it. And for a long time, we wondered if planets were a cosmic rarity. Maybe our solar system, with its neat collection of rocky worlds and gas giants, was a one-off fluke. But then we started looking. Missions like the Kepler Space Telescope stared unblinking at small patches of the sky for years, watching for the telltale dimming of starlight as a planet passed in front of its parent star. And what it found was revolutionary. Planets are not rare. They are common. Outrageously common. The current consensus is that there are likely more planets than there are stars in the Milky Way. Think about that. For every single one of those 200 billion suns, there is at least one world in orbit, and likely more. It seems the universe is a profligate planet maker. So you have an incomprehensible number of stars, and an even more incomprehensible number of planets. The next question is, how many of them are like Earth? How many are in that cozy, not too hot, not too cold, Goldilocks zone, where liquid water, the solvent for life as we know it, could pool on the surface? The estimates here are still fuzzy, but even conservative guesses yield staggering numbers. Some studies suggest there could be as many as 40 billion Earth-sized planets residing in the habitable zones of their stars in our galaxy alone. 40 billion potential cradles for life. 40 billion rocky shores where tides might ebb and flow. 40 billion skies that might have clouds and sunsets of their own. This is where the paradox really begins to bite. Our universe is ancient. It's been around for roughly 13.8 billion years. Our solar system is a relative newcomer, forming about 4.5 billion years ago. That means there have been billions of years, and billions of other star systems, that got a significant head start on us. Imagine a civilization that arose on one of those 40 billion worlds, but just 1% earlier in the galaxy's history. 1% of the Milky Way's age is about 100 million years. What could a species accomplish with a 100 million year head start on humanity? Think about our own progress. A mere 10,000 years ago, we were chipping stones. 500 years ago, we were just figuring out that the Earth wasn't the center of everything. 100 years ago, the idea of splitting the atom or walking on the moon was pure fantasy. Our technological explosion has happened in the blink of a cosmic eye. Now stretch that exponential curve out over 1 million years, or 10 million, or 100 million. It becomes impossible to even conceive of the technologies such a civilization might possess. Let's be conservative. Let's assume that interstellar travel is incredibly difficult and that you can't break the speed of light. Even if a civilization's probes or colony ships traveled at just 1% of the speed of light, a speed we can theoretically imagine achieving, they could cross the entire 100,000 light-year span of the Milky Way galaxy in about 10 million years. 10 million years is a long time for you and me, but it's a geological eye blink. It's less than the time that has passed since our ancestors diverged from the ancestors of modern orangutans. So, if even one civilization had arisen in our galaxy's long history, they should have had more than enough time to spread out, to leave their mark, to be everywhere. And what kind of marks would they leave? Maybe it wouldn't be city lights or physical colonists. An advanced civilization would likely be far more efficient. They might send self-replicating probes, von Neumann probes, that travel to a star system, use the local raw materials to build copies of themselves, and then launch those copies to neighboring stars. A wave of exploration expanding in all directions, exponentially. Such a wave could chart the entire galaxy in 500,000 years. These probes could be tiny, but they would still be artifacts. They might communicate with their home base, or with each other. Their communications would be a web of signals crisscrossing the galaxy. Or maybe they would undertake engineering projects on a stellar scale. A Dyson sphere, for instance, is a hypothetical megastructure that an advanced civilization might build to completely encompass a star and capture all of its energy output. A culture capable of this would be a Type II civilization on the Kardashev scale, a way of measuring a civilization's technological advancement based on the amount of energy it can use. Humanity is currently a Type 0.7 civilization, still drawing our energy from the dead plants and animals of our own planet. A Type II civilization would seem like gods to us. And a Dyson sphere, or even a partial one called a Dyson swarm, would be noticeable. It would block the visible light from a star but radiate a tremendous amount of infrared heat. It would be a screamingly obvious beacon in the sky, an unmistakable sign of intelligent activity. Scientists have looked. Oh, how they have looked. Projects like SETI, the search for extraterrestrial intelligence, have been scanning the radio spectrum for decades, listening for that one, unambiguous, artificial signal amidst the cosmic static. They are listening for the alien equivalent of our television broadcasts, our radar pings, our "I Love Lucy" reruns echoing into the void. All they've heard is silence. The background hiss of the universe. The faint, ghostly hum of the cosmic microwave background radiation, the leftover heat from the Big Bang itself. It's the sound of an empty room. They've also searched for those stellar-scale engineering projects. They've scoured astronomical data for stars that seem to be dimming erratically or giving off way too much infrared radiation. There have been a few tantalizing candidates, like Tabby's star, which showed some very strange and dramatic dips in brightness. For a moment, the world held its breath. Could this be it? An alien megastructure? But further investigation suggested it was likely a massive cloud of cosmic dust. Every time, a natural explanation has so far fit the data better. It's like finding what you think is a footprint on a deserted beach, only to realize it was just a weirdly shaped rock. So you have this profound contradiction. On one hand, the numbers, the stars, the planets, the time, insist that the galaxy should be a bustling, noisy metropolis of civilizations. On the other hand, the empirical evidence, our telescopes, our radio dishes, shows us a silent, seemingly empty wilderness. This is the Great Silence. It's a chilling, deeply unsettling cosmic mystery. It's Fermi's question echoing in an apparently empty hall. Where is everybody? The silence itself feels unnatural. If you walk into a forest on Earth and hear no birds chirping, no insects buzzing, no rustle of leaves, you don't think, "Ah, what a peaceful, empty forest." You think, there is a predator nearby. The silence is a warning. Is the cosmic silence a warning? Are we the naive little creature, chirping away on our little blue world, unaware of some unseen cosmic predator that has silenced all the others? That's a chilling thought, and it's one possible answer to the paradox. But let's not get ahead of ourselves. You're still there, floating in the dark, contemplating this immense quiet. You feel the scale of the question pressing in on you. It's not just an academic puzzle, it feels personal. You look at human history, our squabbles, our triumphs, our art, our cruelty, and you wonder if we are truly the only ones having this experience. Is this it? Is this one tiny planet the only stage on which the drama of self-awareness has ever been performed in this entire galaxy? Scientists still debate the core uncertainty. Is the bottleneck the emergence of life itself? Is the jump from non-living chemistry to a replicating cell a once-in-a-galaxy fluke? Or is the bottleneck later? Is it the jump to complex, multicellular life? Or is it the final, perhaps most perilous leap, the development of a technological intelligence that doesn't quickly drive itself to extinction through war or environmental collapse? We simply don't know where the great filter, as it's called, might lie. You might find a strange, almost absurd comfort in a piece of unverified cosmic graffiti, the famous "Wow" signal. In 1977, a radio telescope in Ohio picked up a powerful, narrowband radio signal lasting for 72 seconds. It came from the direction of the constellation Sagittarius. It was so striking, so unlike any natural phenomenon, that the astronomer on duty, Jerry Emin, circled the printout and wrote, "Wow," in the margin. It was exactly the kind of signal SETI was looking for. It was a ghost, a whisper that seemed to prove we weren't alone. But here's the rub, we've pointed our telescopes back to that same patch of sky hundreds of times since, and we've never heard it again. It was a one-time cosmic phone call from an unknown number, with no message left. It's a weird little footnote in the story of the search, a piece of data that offers more questions than answers. Was it them? Was it a previously unknown natural phenomenon? A satellite passing by in just the wrong way? Or was it just the universe making a prank call? The silence presses on. It's a canvas onto which we project our greatest hopes and our deepest fears. Hope that we are not alone, that there are others to learn from, to talk to share the universe with. And fear. Fear that we are alone, and the responsibility of that is crushing. Or fear that we are not alone, and that the silence is deliberate. That they are out there, but for some reason they are hiding. Or worse, that they are watching. This brings us to the edge of an even stranger idea. What if the lack of evidence is the evidence? What if the silence isn't an absence, but a presence? What if the forest is quiet not because of a predator, but because of a hidden observer? A zookeeper, perhaps. The idea is that the universe isn't empty at all. It's full. But we've been placed off limits. You, your world, your entire history, are part of a grand exhibit. A cosmic nature preserve. And the number one rule for all visitors is a simple one. Do not tap on the glass. The silence, in this scenario, is the sound of everyone else holding their breath, waiting to see what the strange creatures on the third planet from a middling yellow star will do next. It's an elegant, if slightly terrifying, solution to Fermi's paradox. It presupposes a level of technological and social maturity on the part of the aliens that is, from our vantage point, almost divine. And it recasts our cosmic loneliness not as a tragedy, but as a carefully curated quarantine. So, let your mind settle on that image for a moment. You are not lost in an empty void. You are the star attraction in the most exclusive zoo in the universe. The silence you hear is the soundproofing of your enclosure. The emptiness of the sky is the ultimate. Do not disturb. Sighing. Every star you see could be a home to one of the onlookers, the patrons of this galactic zoo. They know we're here. They've known for a long time. But they have collectively agreed to leave us alone, to let our bizarre, beautiful, and often self-destructive story unfold on its own terms. At least for now. It's a hypothesis that flips the entire problem on its head. The question is no longer, where is everybody? It's, why are they being so quiet? And that is a much more interesting question. You are left with that lingering image, the universe as a grand auditorium, and humanity as the sole performer on a single, brightly lit stage. But the audience isn't empty, it's just hidden in the shadows, holding a collective, silent breath. The silence is a choice. This is the foundation of what has come to be known as the zoo hypothesis. It's a tantalizing, elegant, and deeply unsettling idea, first formally proposed in a scientific paper by MIT radio astronomer John Ball in 1973. He looked at the same puzzle as Enrico Fermi, the Great Silence, and proposed that the silence itself was the message. He suggested that we are not alone, but are instead part of a vast, protected cosmic wilderness. Imagine, for a moment, that you are a field biologist. You want to study a newly discovered, uncontacted tribe in the heart of a dense rainforest, or perhaps a fragile colony of emperor penguins in the Antarctic. What is your primary directive? It is to observe without disturbing. You use camera traps, long-range lenses, and discrete microphones. You camouflage your presence. The goal is to see the subjects in their natural state, to understand their social structures, their behaviors, their evolution, without the corrupting influence of your own presence. Your interference, no matter how well-intentioned, would irrevocably alter the very thing you are trying to study. You would cease to be an observer and become an actor in their story. Now scale that principle up to a galactic level. In this scenario, you and every other living thing on Earth are the subjects. The advanced alien intelligences are the field biologists. Earth is the untouched rainforest, a planetary-scale nature preserve. They have designated our world, perhaps our entire solar system, as a hands-off zone. This isn't a zoo in the sense of iron bars and concrete enclosures. You are not pacing in a cage. The cage is your own technological infancy. The bars are the unfathomable distances between the stars, distances that are trivial for the zookeepers to cross, but impossible for you. The zookeepers don't need to lock the door because you haven't yet figured out how to build a key, or even what a key is. They watch. From where? Perhaps from cloaked observation posts hidden in the asteroid belt, or deep in the Oort cloud at the edge of our solar system. Perhaps their sensors are so advanced they can observe us in real time from their home worlds light years away, using technologies that bend space-time in ways we can only dream of. Maybe they use probes no larger than a grain of sand, drifting invisibly through our atmosphere, collecting data on everything from the planet's atmospheric composition to the latest memes trending on the internet. You take a breath, and you wonder if it's being recorded, analyzed, and archived in some galactic library of developing worlds. Every war, every symphony, every act of kindness, every meme stock rally, it's all just raw data for the observers. It's the ultimate reality television show, broadcast across the stars. They're probably on season 4.5 billion right now, and the current story arc with the self-aware apes is getting particularly interesting. The core assumption of the zoo hypothesis is a staggering difference in power and maturity. The zookeepers would not be just a few centuries or a few millennia ahead of us. To enforce a galactic quarantine, to remain perfectly hidden from our most sensitive instruments, they would need to be millions, perhaps even a billion years more advanced. Their understanding of physics, of energy, of consciousness itself, would be as far beyond ours as our understanding is beyond that of a squirrel. Have you ever tried to explain calculus to a squirrel? You wouldn't even know where to begin. The concepts are simply outside its cognitive framework. To this galactic society, we might be the squirrels, charming, occasionally clever, but utterly incapable of comprehending their reality. This idea branches into a few different flavors. The first is the perfect zoo. In this version, the isolation is absolute. The zookeepers are masters of their craft. Their technology is flawless, their discipline unwavering. There are no leaks, no glitches, no hints of their presence. They are the perfect, silent observers. In this scenario, we would have absolutely no way of knowing they are there. The great silence would be pristine and unbroken, and any speculation like this would remain pure philosophy, forever unprovable. It's a clean, but somewhat unsatisfying version of the theory. Then, there's a more intriguing possibility, the leaky zoo. Perhaps the quarantine isn't perfect. After all, managing an entire planet full of unpredictable, semi-intelligent beings from light years away must be a complex operation. Maybe, just maybe, there are occasional mistakes. A cloaked probe suffers a minor malfunction and is briefly visible on a fighter pilot's radar. A communication beam between observation posts accidentally gets pointed toward a radio telescope in Ohio for 72 seconds. You remember the "wow" signal, don't you? In a leaky zoo, that wasn't a prank call. It was a wrong number, a brief, accidental glimpse behind the curtain before the zookeepers realized their error and shut it down. UFOs, or UAPs as they are now more soberly called, would fit neatly into this version of the hypothesis. The strange, non-aerodynamic objects reported by credible witnesses, performing maneuvers that defy our known laws of physics. Perhaps they aren't invasion fleets or visiting dignitaries. Perhaps they are the equivalent of a park ranger's drone getting a little too close to the wildlife. Or maybe, and this is a more provocative thought, the leaks are intentional. Little nudges. Carefully curated, unexplained, events designed to slowly acclimate us to the idea of a wider cosmic neighborhood without causing mass panic or cultural collapse. They are testing the waters, seeing how the squirrels react when they see a strange glint of metal high in the trees. There's a further, slightly more unnerving variation of this idea, the laboratory hypothesis. This proposes that we are not just being preserved, we are being studied. Earth is not a wilderness, it is a petri dish. Our evolution, our social development, our very consciousness might be part of a long-running experiment. Are they testing a hypothesis about the emergence of intelligence? Are they studying how societies deal with self-inflicted crises like climate change or nuclear proliferation? A scientist studying an ant farm doesn't just watch. Sometimes, they introduce a new variable, a drop of honey here, a new obstacle there, to see how the colony reacts. In the laboratory hypothesis, major events in human history might not be entirely our own doing. Was the sudden spark of the cognitive revolution 70,000 years ago a natural development? Or was it the result of a subtle, external nudge? It's a deeply paranoid thought, undermining our sense of free will. But in the context of a civilization a million years our senior, it's a chillingly plausible one. One of the oddest, most specific offshoots of this line of thinking is the galactic heritage concept. This suggests that planets like Earth, planets where life has arisen independently, are designated as cosmic treasures. They are preserved not just to protect the inhabitants, but to protect the integrity of the evolutionary process itself. It's like a UNESCO World Heritage Site, but on a planetary scale. The goal is to preserve the natural history of a planet from the moment of abiogenesis, the origin of life from non-living matter, all the way to the development of intelligence and beyond. Interfering would be akin to demolishing the pyramids to build a new hotel. It would be an act of cosmic vandalism. Our planet's value, in this case, comes from its pristine, unadulterated state. We are a living museum of what the universe can do when left to its own devices. This forces you to reevaluate your own place in the cosmos. Your entire sense of importance shifts. On one hand, it's profoundly validating. We are not just another boring rock. We are interesting. We are so fascinating that a godlike super-civilization has decided we are worth preserving and observing. Every piece of art we create, every scientific discovery we make, is potentially being appreciated by an unseen, ancient audience. It elevates our story from a local drama to a performance on the galactic stage. But on the other hand, it's utterly terrifying. It reduces us to mere specimens. We are not peers, we are pets. Our greatest achievements are just curious behaviors, noted down in an observer's logbook. Our struggles, our wars, our heartbreaks are entertainment. The label on our cosmic exhibit might read something like, Homo sapiens, a fascinatingly paradoxical species of primate from the Sol system, demonstrates capacity for both breathtaking artistic expression and baffling self-destruction, prone to anxiety and periods of irrational exuberance. Caution, do not engage. The subjects are considered volatile and have not yet passed their planetary adolescence. Scientists still debate the plausibility of this entire scenario. The biggest hurdle is the question of unanimity. For the zoo hypothesis to work, it would require that every advanced civilization in the galaxy agrees to abide by the non-interference rule. Every single one. Think about humanity. Can we agree on anything? We have hundreds of nations, thousands of cultures, and billions of individuals, all with their own agendas. The idea that a multitude of independent alien species, with their own histories, biologies, and ethics, would all converge on the exact same hands-off policy seems statistically unlikely. All it takes is one dissenter, one rogue civilization, or even one rebellious individual within a civilization, who decides to break the rules and make contact. The maverick, the missionary, the exploiter, the cosmic shock jock who just wants to see what happens when you tell the monkeys about quantum mechanics. Where are they? This leads to the idea that perhaps there isn't a multitude of civilizations. Perhaps the zookeeper is a single, ancient, incredibly powerful civilization that arose first. A firstborn species that now polices the galaxy, enforcing the quarantine on all other emerging life forms. This entity would be so old and so powerful that no newcomer could possibly challenge its authority. It would be the de facto government of the Milky Way, and its prime law is non-interference. This solves the unanimity problem but replaces it with the equally daunting concept of a single, galactic hegemon. Are they benevolent protectors, as the zoo analogy implies? Or are they tyrants, jealously guarding their power and preventing any potential rivals from ever reaching the galactic stage? The silence, in that case, is the silence of oppression. You feel the weight of these possibilities. You walk outside and look at the sky, at your fellow humans rushing about their lives, and you wonder, are we really in control of our own destiny? Is our history truly our own? The zoo hypothesis creates a profound sense of cognitive dissonance. It suggests we are simultaneously the most important thing on the planet and the least important thing in the galaxy. We are the protagonists of our own story, and a footnote in someone else's. It recasts the world in a new light. The mundane becomes mysterious. A bird singing in a tree is just a bird. But what if its song is being recorded and analyzed for its syntactical complexity by a being with 1,000-year lifespan? The internet, our great global conversation, becomes something more. What if it's the most fascinating data stream the zookeepers have ever found? A direct, real-time feed into the collective consciousness, the ID, of a developing species. It's messy, it's chaotic, it's full of contradictions. It must be absolutely riveting for them. Maybe they even have their own version of academic papers, debating our trajectory. A quantitative analysis of feline videos as a mechanism for social cohesion in early-stage planetary networks. You find yourself in this strange mental space, caught between a feeling of cosmic insignificance and cosmic celebrity. Are we just another biological experiment? Or are we the universe's greatest work of art? A story so compelling that the gods themselves have chosen to sit back and watch it unfold? The zoo hypothesis doesn't give you an answer. It just deepens the mystery. It takes the cold, empty silence of the Fermi paradox and fills it with the ghost of a presence. The feeling that you are alone is replaced by the feeling that you are being watched. and you are left to wonder which feeling is more frightening. The silence is not an absence of life, but a testament to its discipline. It is the sound of the zookeepers respecting the sanctity of the enclosure, patiently waiting, watching, and wondering what you will do next. The feeling settles upon you, the disquieting sense of being watched by an unseen, silent audience. The zoo is no longer just a wild hypothesis. It has become a tangible mental space. But this raises the most important question of all. Why? Why would a civilization, or a collection of civilizations, with the power to reshape stars and cross galaxies, choose to do nothing? Why the silence, the secrecy, the painstaking effort of non-interference? The answer may lie not in physics or technology, but in something far more developed: ethics. An ethical framework so profound and so binding that it can unite a galaxy in shared purpose. You might know it best from fiction. The Prime Directive, from Star Trek. It's a concept that has permeated our culture, a simple and elegant rule: you do not interfere with the internal development of other cultures. Specifically, you do not reveal yourself or your technology to any species that has not yet developed interstellar travel on its own. For the crew of the Starship Enterprise, it was the highest law, a moral absolute that created their most compelling ethical dilemmas. But this idea is likely far more than just a clever plot device for a television show. It may be an inevitable conclusion that any truly advanced, space-faring society must reach if it is to survive and act responsibly. Let's step into their shoes for a moment. Not as zookeepers, but as guardians. You belong to a civilization that has seen the galaxy, that understands the diversity of life and the fragility of cultures. You have a historical record that spans millions of years. And now your long-range sensors detect a faint, interesting signal from a small, watery planet in the Orion Arm. A world of astonishing biological diversity and a dominant species that is just now beginning to understand its own planet and the atom. They call themselves humanity. Your first impulse might be one of joyous discovery. You want to make contact, to share, to welcome them into the galactic community. But then you consult your history, your own, and that of countless other worlds you have observed. And you see the pattern, repeated over and over again. You see what happens when a high-technology culture makes contact with a low-technology culture. You don't even need to look to the stars for examples. You can see it in humanity's own brief, violent history. Think about the arrival of European explorers in the Americas, or in Australia, or in the islands of the Pacific. The intention, at least in some cases, may have been benign curiosity or a desire to civilize. But what was the result? The result was devastation. Not always through deliberate malice, but through an unavoidable collision of contexts. The visitors brought diseases for which the native populations had no immunity, wiping out millions. Smallpox, measles, and influenza were more effective conquerors than any army. They introduced technologies, steel, firearms, alcohol, that shattered existing social structures, economies, and traditions. They introduced religions and philosophies that undermined and erased millennia of cultural identity. The indigenous people were overwhelmed. Their world was irrevocably broken. Their story, which had been their own for generations, was suddenly over, replaced by a new one in which they were a subjugated, marginalized chapter. Now, amplify that disparity by a million years. An alien vessel lands in a public park. They step out, beings who have mastered energy, gravity, and perhaps even mortality itself. They mean us no harm. They only want to help. They offer us a cure for every disease, cancer, Alzheimer's, aging itself. What happens to our society? Our entire medical industry, a huge part of the global economy, vanishes overnight. Our religions, many of which are centered on concepts of suffering, mortality, and an afterlife, are thrown into existential chaos. Our social structures, built around the biological imperatives of aging and procreation, become meaningless. We are a species defined by our finitude, and they have just casually erased it. It would be a gift that poisons the recipient. Then, they offer us their energy source. A simple, elegant device that pulls limitless, clean energy from the vacuum of space-time. No more climate change. No more resource wars. It sounds like utopia. But what happens to the global power structure, which is largely based on the control of fossil fuels and other energy resources? The geopolitical map is redrawn in a single day. Nations whose wealth is based on oil become irrelevant. The ensuing economic and political chaos could easily lead to wars far more devastating than any fought over the resources themselves. We would be like children fighting over a new toy, and this toy has the power to level cities. The non-interference directive is based on this simple, painful wisdom. Giving a toddler a loaded weapon is not an act of kindness. It is an act of gross negligence. The aliens might look at our current state, our tribalism, our conflicts, our struggle to manage the technologies we already have, and conclude, with a kind of sad pity, they are not ready. The Prime Directive isn't just to protect us from them, it's to protect us from ourselves. Beyond the immediate hazards of cultural contamination and technological shock, there is a deeper, more philosophical reason for non-interference. It's the principle of natural development. It is the belief that every species has the right to its own journey. The right to make its own mistakes, to learn from them, and to find its own solutions. The right to its own story. Imagine you are climbing a great mountain. It is a difficult, arduous climb. You struggle, you fall, you learn. The view from the top is earned through your own effort, your own perseverance. The struggle is what gives the achievement its meaning. Now imagine that just as you are about to reach the summit, a helicopter descends and drops you on the peak. You are at the top, but you did not get there. You were placed there. The experience is hollow. The victory is meaningless. Interference from an advanced race would be that helicopter. Our struggles with poverty, disease, war, and environmentalism are our mountain. They are the great challenges that will define our maturity as a species. If we solve them, we will have earned our place as a stable, planetary civilization. We will have climbed the mountain ourselves. If aliens arrive and solve these problems for us, they will have stolen our triumph. We would forever be their protégés, their dependents. Our future would be a gift, not an achievement. A truly wise and ethical civilization might see this and conclude that the greatest gift they can give us is the gift of being left alone. They honor our struggle by refusing to intervene in it. This puts you, the listener, in a difficult ethical position. Imagine you could travel back in time. You see a child about to run into a busy street. Your instinct is to grab them, to save them. That is direct, compassionate intervention. But what if the child is an entire species, and that busy street is their own adolescence? Saving them from one danger might prevent them from learning the critical lesson of looking both ways before crossing. Philosophers and astrobiologists still debate this very point. Is the Prime Directive an act of supreme empathy, a recognition of another's autonomy on the grandest scale? Or is it an act of supreme arrogance? Is it a judgment made from on high, that we are too primitive, too childlike to be engaged with as equals? It's a fine line between a respectful naturalist and a condescending zookeeper. There's also a more esoteric, almost artistic motivation they might have. Think of the universe as a grand creative process. Each time life arises on a planet, it's a unique, unrepeatable experiment. The specific chemistry of the oceans, the tilt of the planet's axis, the radiation from its star, the random mutations in its first self-replicating molecules. All these factors lead to a unique evolutionary pathway. The result is a biosphere, a story that has never existed before and will never exist again. An advanced species of connoisseurs might view these emerging biospheres as great works of art. They are not paintings or sculptures, but living, evolving masterpieces of cosmic chance and necessity. From this perspective, our Earth is a one-of-a-kind masterpiece. The chaotic, beautiful, violent story of life here, from the first microbe to the dinosaurs to the rise of human consciousness, is a unique aesthetic object. To interfere would be to splash your own paint on a Rembrandt. It would be an act of unforgivable vandalism. Their non-interference might not be about protecting us, so much as it is about preserving the artistic integrity of the piece. They are the curators of a galactic museum of natural art, and their prime directive is simple: you don't touch the exhibits. This might seem like a strange, cold way to view things, but for a consciousness that has lived for millions of years, the long, slow unfolding of planetary evolution might indeed be the most beautiful art form there is. You can almost picture the internal debate within their society. The activists, arguing for intervention. Look at them! They are on the verge of destroying their beautiful planet. We have a moral obligation to step in and save them. And then the traditionalists, the preservers, countering them. And replace their unique struggle with our generic, homogenized solutions? We would be destroying the very thing that makes them special. Let them face their crisis. Let them have their moment. Their potential for greatness is tied to their freedom to fail. Their non-interference policy might be the result of a long and difficult debate, a hard-won political and ethical consensus. The Manual for New Field Agents Observing Earth probably has an entire, very thick chapter titled, The Homo Sapiens Problem, a Case Study in Non-Interventionist Ethics. So, the Prime Directive is not a single, simple idea. It's a complex tapestry woven from threads of pragmatism, ethics, and maybe even aesthetics. It's born from the painful wisdom that power must be wielded with restraint. It's the ultimate expression of the principle. First, do no harm. It is the software that runs the zoo we described in the last section. It is the why behind the what. The silence from the stars is not empty. It is the sound of respect. It is the sound of a promise being kept. A promise to let us find our own way, to climb our own mountain, to write our own story, no matter how it ends. They are giving us the freedom not only to succeed, but also to fail, on our own terms. And as you stand under the quiet stars, you are left to wonder if we will use that freedom wisely. You are left with this profound ethical framework, the Prime Directive, a galactic promise of non-interference. It's a comforting thought, in a way. The silence from the cosmos is not one of emptiness, but one of respect. But you are a creature of evidence. A member of a species that learned to thrive by testing, by measuring, by demanding proof. A noble philosophy is one thing, but is there any actual, tangible evidence to support this wild idea of a cosmic zoo? Can we find any fingerprints left behind by our silent, unseen keepers? The search for evidence is where this hypothesis moves from pure philosophy into the murky, speculative territory of science and observation. And you have to begin with the most powerful, albeit paradoxical, piece of evidence there is, the great silence itself. You remember the paradox we started with, don't you? The universe is vast and old, filled with potentially habitable planets. By all statistical logic, it should be teeming with detectable life. The fact that it is not, the fact that the sky is so unnaturally quiet, is the primary anomaly we need to explain. Most solutions to the Fermi paradox try to explain why life isn't there. Maybe it's incredibly rare. Maybe civilizations always destroy themselves. But the zoo hypothesis takes a different approach. It suggests the life is there, but is deliberately hiding itself from us. In this context, the profound, deafening silence is not evidence of absence, it's evidence of discipline. It's so complete, so total, that it feels artificial. Imagine walking into a jungle that you know is full of animals, but you don't hear a single sound. Not a bird, not an insect, not a rustle. You wouldn't conclude the jungle is empty. You would conclude that something is making everything hide. The great silence, from this perspective, is the sound of the entire galaxy holding its breath whenever it looks in our direction. It is the single greatest clue that we are being quarantined. But an argument from absence, while elegant, can feel unsatisfying. It's like trying to prove the existence of a perfect ninja by the fact that you've never seen one. You hunger for something more positive, a direct sign, a glimpse behind the curtain. And this is where we must turn to the controversial, highly charged topic of unidentified anomalous phenomena, or UAPs, what you have always known as UFOs. For decades, the subject was relegated to the fringes, a playground for conspiracy theorists and late-night talk shows. But something has shifted. In recent years, the conversation has become serious. Consider the incident from 2004, involving the USS Nimitz carrier strike group off the coast of California. Multiple highly trained U.S. Navy pilots, from multiple vantage points, over the course of 2 weeks, reported encounters with smooth, white, oblong objects that came to be known as the Tic-Tacs. These objects were tracked on some of the most advanced radar systems in the world. They were seen with human eyes, and they were recorded on infrared camera. The pilots, people like Commander David Fravor, were seasoned professionals, not prone to fantasy. They described an object that defied our understanding of physics. It hovered motionless over a disturbance in the water, then accelerated to hypersonic speeds in an instant, with no visible means of propulsion, no wings, no engines, no hot exhaust plume. It moved in ways that would subject a human pilot to G-forces that would be instantly fatal. This is not an isolated incident. The Pentagon has declassified numerous similar reports, and pilots continue to come forward with stories of objects that seem to operate with impunity in protected military airspace. These UAPs are often described as exhibiting what have been called the 5 observables. First, anti-gravity lift, the ability to hover silently, without rotors or jets. Second, sudden and instantaneous acceleration, changing speed and direction with a sharpness that defies inertia. Third, hypersonic velocities without signatures, moving faster than the speed of sound without creating a sonic boom or displaying the heat friction you'd expect. Fourth, low observability. They seem to have the ability to cloak themselves, appearing and disappearing from radar and sight at will. And fifth, transmedium travel. The ability to move seamlessly from the air into the water and back again. Let's be absolutely clear, none of this is definitive proof of aliens. Scientists are rightly skeptical and are exploring every possible prosaic explanation. Could it be secret human technology from another nation? Unlikely, given the physics involved seem to be a century or more ahead of our own public science. Could it be some unknown atmospheric or plasma phenomenon? Perhaps, but it doesn't quite fit the data of solid, craft-like objects under intelligent control. Could it be sensor malfunctions or pilot misidentification? In some cases, certainly. But in cases like the Nimitz incident, the data comes from multiple platforms and multiple witnesses, making that explanation difficult. Now, look at this phenomenon through the lens of the leaky zoo hypothesis. If an advanced civilization were observing us, what would their drones be like? They would likely exhibit those exact 5 observables. They would be quiet, fast, stealthy, and able to go wherever they needed to, air or sea, to gather data. The UAP phenomenon, in this context, is not an invasion. It's not a clumsy attempt at contact. It's the zookeeper's equipment occasionally malfunctioning. It's a cloaking device that flickers for a moment. It's a drone that gets a little too close to the animals and gets caught on camera before zipping away. You can almost picture the alien technician having to file a report. Observation drone number 734, log entry 8,472,941. Subject F-18 pilot displayed elevated heart rate and vocalized profane surprise. Cloaking shimmer was outside of acceptable parameters for 0.78 seconds. Must recalibrate the plasma manifold before next observation run. The UAP evidence doesn't prove the zoo hypothesis, but it is remarkably consistent with what you would expect to see if the hypothesis were true. Beyond these dramatic, but rare, glimpses, are there other, more subtle clues? This is where we venture into even deeper, more philosophical waters. Some have pointed to the apparent fine-tuning of the universe itself. The fundamental constants of physics, the strength of gravity, the charge of an electron, the cosmological constant, seem to be set on a razor's edge. If any of them were even slightly different, stars wouldn't form, chemistry would be impossible, and life as we know it could not exist. This is often used as a philosophical argument for a creator. But in the laboratory hypothesis, a variation of the zoo, this fine-tuning could be seen as evidence of design. Perhaps our universe isn't the only one. Perhaps it's one of many experiments, a custom-built petri dish where the laws of physics were specifically chosen to see if life would emerge. This is, of course, wildly speculative and likely unprovable, but it's a thought that hums in the background of modern physics. Then there's the evidence from our own biology. The history of life on Earth is not a smooth, gradual ramp of increasing complexity. It's marked by sudden, dramatic leaps. The Cambrian explosion, about 540 million years ago, saw the sudden appearance of nearly every major animal phylum in a geological blink of an eye. More recently, the cognitive revolution about 70,000 years ago saw our own species, Homo sapiens, suddenly develop the capacity for abstract thought, symbolic language, and complex culture, allowing us to rapidly outcompete all other human species. Again, the overwhelmingly likely explanation for these events is a complex interplay of natural evolutionary pressures. But a dedicated proponent of the laboratory hypothesis might see the hand of the experimenter. A subtle tweak to the genetic code here, a change in the environment there, just to see what would happen. It's a paranoid interpretation of our own history, but it's an interpretation that the hypothesis allows for. This line of thinking has a modern, digital cousin, the simulation argument. Popularized by philosopher Nick Bostrom, it suggests that given the likelihood that civilizations can develop computing power capable of simulating an entire universe, it is statistically probable that we are living inside one of these simulations. We are not biological beings in a physical zoo, we are artificial consciousnesses in a digital one. The aliens are the programmers, the beings running the simulation. The evidence here is even more abstract. It's the fact that our universe can be described so perfectly by mathematics. It's the strange, pixelated nature of reality at the smallest, quantum scales, the Planck length, where space and time seem to break down into discrete units. That's not to say reality is pixelated, but the metaphor is a powerful one. If we are in a simulation, a glitch in the matrix, and a UAP sighting might be two different descriptions of the same event, a flaw in the code, an asset that fails to render correctly. It's the ultimate paranoia, the feeling that not only are you being watched, but that you, and the very ground beneath your feet, are not even real. It must make for some interesting cosmic tech support calls. Yeah, hi, my simulation of Universe 7 Gamma is lagging again. I think the humanity subroutine has too many active users and it's hogging all the processing power. Of course, the scientific community remains sharply divided on the value of any of this, especially the UAP data. Many scientists rightly dismiss it as a distraction, a collection of sensor noise, atmospheric effects, and human error that is unworthy of serious attention. They argue that extraordinary claims require extraordinary evidence, and a few fuzzy infrared videos are not it. But a small but growing minority of scientists, and a significant portion of the defense and intelligence community, are now arguing that the phenomenon, whatever its origin, is real and deserves sober, data-driven investigation. The debate is no longer about whether the pilots are seeing something, it's about what they are seeing. This brings us to a quirky, and frustrating, aspect of the search called archaeological SETI. The idea is to stop listening for distant signals and start looking for artifacts right here in our own solar system. If a civilization has been observing us for thousands of years, maybe they left something behind. A discarded probe, a monitoring station, a marker buoy. People have proposed searching for such objects on the Moon, in the asteroid belt, at the stable Lagrange points in our orbit. So far, we found nothing. Not a single, unambiguous alien artifact. And this lack of evidence is a paradox within the paradox. For a skeptic, it's proof that they were never here. But for a believer in the zoo hypothesis, it's just more evidence of their incredible skill. They are not just good zookeepers, they practice a perfect, leave no trace, philosophy. So you are left in a strange place. There is no smoking gun, no crashed saucer, no alien body, no unambiguous "we are here" message. All you have are shadows and echoes. You have the deafening silence of the cosmos. You have the fleeting, inexplicable lights in the sky seen by credible witnesses. You have the philosophical questions about the nature of our reality and the strange, sudden leaps in our own past. None of it is proof. But when you bundle it all together, it begins to paint a picture. It's a speculative, hazy picture, to be sure. But it's a picture that is consistent with the idea that we are being watched by a silent, patient, and incredibly advanced intelligence. The evidence doesn't force you to believe, but it does invite you to wonder. You are standing in the center of the enclosure, contemplating the shadows and echoes that might constitute evidence for your confinement. The silence, the fleeting lights, the philosophical quandaries. But now, you must turn your attention from the why and the if to the how. If this galactic zoo is real, if there are keepers observing you right now, what is the nature of their technology? What kind of science, what kind of engineering would be required to pull off a feat of this magnitude? To watch an entire, evolving planet for eons, all without leaving a single, definitive trace. The technological gulf would be so vast it makes the gap between a modern smartphone and a sharpened stick look like a tiny crack in the pavement. You must begin with the most fundamental principle of the zoo, undetectability. The Keeper's primary technological challenge is to overcome your own ever-increasing ability to see. A few thousand years ago, all they had to do was stay out of sight of the naked eye. A few hundred years ago, they had to contend with rudimentary telescopes. Now you have a global network of eyes. You have radio telescopes listening to the cosmos, optical telescopes that can read a newspaper from orbit, particle detectors buried deep underground, and space probes venturing to the outer edges of the solar system. You are a species that is constantly looking, listening, and searching. To remain hidden from you is a monumental task that requires a mastery of physics we can barely begin to imagine. Let's start with how they watch. They wouldn't use anything as crude as active radar, which sends out a pulse and waits for a bounce. That pulse is a shout in the dark, easily detectable by a species like ours that has learned to listen for such things. No, their observation would have to be entirely passive. They would be the ultimate eavesdroppers. Imagine sensors that don't detect light or radio waves, but gravity itself. A network of gravity sensors hidden in the asteroid belt could potentially detect the movement of every car on Earth, the construction of every new building, the shifting of magma beneath the continents, all by measuring the infinitesimal ripples in space-time caused by these changes in mass. They would see everything on the planet not as a picture, but as a constantly changing gravitational map of exquisite detail. Or perhaps they use neutrinos. Trillions of these ghostly subatomic particles are passing through your body and the entire Earth every second, products of our Sun and distant cosmic events. They interact with almost nothing, making them incredibly difficult to detect. That's a problem for our scientists, but for a super-advanced civilization, it's a feature, not a bug. They could have engineered a way to send and receive focused neutrino beams, allowing them to pass through the entire planet and create a three-dimensional, real-time scan of everything happening on the surface and even deep within its core, all without leaving a single energetic trace that we could ever hope to find. Then there is the truly exotic possibility of quantum sensing. You've heard of quantum entanglement, the spooky action at a distance that so bothered Einstein. Two particles become linked, and no matter how far apart they are, a change in one is instantly reflected in the other. What if the Keepers have mastered this? They could release quadrillions of entangled dust particles into our atmosphere, our oceans, our soil. The particles would be no different from any other atoms, completely invisible to our analysis. But back on their observation posts, perhaps light years away, they hold the other half of each entangled pair. By monitoring their local particles, they would have a live, instantaneous feed of information from every corner of our world. They would know the precise chemical composition of the air you are breathing right now, not by taking a sample, but by reading a particle on a screen a trillion miles away. It's a technology that is, to us, indistinguishable from magic, which is precisely what Arthur C. Clarke said any sufficiently advanced technology would be. Now, consider the technology of their probes, those tic-tacs, those UAPs we discussed. How do they achieve their invisibility, their low observability? It wouldn't just be a coat of radar-absorbent black paint. They would need active, dynamic cloaking. They would likely use something called metamaterials. These are not materials found in nature. They are substances engineered at the atomic level to have properties that seem impossible. A metamaterial cloak would be able to bend light waves, radio waves, and any other form of electromagnetic radiation perfectly around the object, like water flowing around a smooth stone. From your perspective, you would see right through it. The light from the stars behind it would reach your eyes perfectly, without distortion. The object would not cast a shadow. It would simply not be there in any detectable way. But even a perfect metamaterial cloak might not be enough. To explain the lack of sonic booms or heat friction from hypersonic movement within our atmosphere, you have to go a step further. You have to consider the possibility that they are not just hiding the craft, but hiding its interaction with our environment. This points toward the holy grail of physics, the direct manipulation of space-time. If a craft can generate a localized, warp bubble around itself, it's not really flying through the air in the way a plane does. It's moving a pocket of space, and the craft is just sitting inside it. The air doesn't rush past it. The space in front of it is contracted, and the space behind it is expanded. It moves without ever truly touching its surroundings. This would not only explain the silence and the lack of heat, but it would also protect the craft and any occupants from the crushing G-forces of instantaneous acceleration. The craft isn't accelerating, the bubble of space is. It's the ultimate cheat code for physics as we know it. Of course, to power such technologies, gravity sensors, neutrino beams, space-time warping propulsion, would require an energy source of unimaginable power and efficiency. Their probes would not be running on jet fuel or nuclear fission. They would have likely mastered what we call zero-point energy, the ability to pull usable energy directly from the quantum foam of the vacuum of space itself. In every cubic centimeter of empty space, there is a roiling sea of virtual particles, a tremendous potential energy that we have no idea how to tap. They would have figured it out. Their probes would have functionally infinite range and power, drawing their fuel from the very fabric of reality as they move through it. Or perhaps they use controlled matter-antimatter annihilation, a process 1,000 times more efficient than nuclear fusion. These are the kinds of energy sources you need when your civilization measures its power output on the Kardashev scale. This entire, extraordinary technological ecosystem, the sensors, the cloaking, the propulsion, raises another critical question: who is running it? A project on this scale, lasting for potentially millions of years, cannot depend on the whims and short lifespans of biological beings. The original keepers who may have set up the zoo could be long extinct. The system would have to be almost entirely, if not completely, automated. The true zookeeper, the true guardian of the Prime Directive, would almost certainly be an artificial superintelligence, or ASI. This is not the kind of AI you interact with on your phone. This would be an intelligence as far beyond a human as a human is beyond a flatworm. It would be an immortal, patient, thinking entity, its consciousness distributed across a network spanning the solar system or beyond. Its sole purpose, to observe Earth, to analyze the data, and to ensure the quarantine is never, ever breached. It would watch civilizations rise and fall on Earth. It would watch continents drift. The passing of 1,000 human years would be like a moment to it. It would learn, it would adapt its methods as our technology grew, always staying 1, or 10,000, steps ahead. It would be the perfect, incorruptible, and utterly inscrutable warden. When a Navy pilot sees a tic-tac, it might be this AI making a rare, infinitesimal error in calculation, or perhaps running a specific test on our detection capabilities before correcting the anomaly. A light joke comes to mind: the AI might have different settings for its probes, including a "don't spook the primates" mode that it usually keeps enabled. One of the great debates among physicists is whether mastering technologies like gravity control would require a theory of everything, a single, unified framework that connects Einstein's general relativity, which governs the very large, with quantum mechanics, which governs the very small. We've been searching for this theory for a century. The mere existence of a craft that can manipulate gravity at will would be definitive proof that such a theory is not only possible but has been turned into an engineering discipline. And here is a truly strange, unconventional thought. What if their technology is not manufactured but grown? What if, after millions of years of development, the line between machine and organism has been completely erased? Their probes might not be built in a factory, but gestated. A spaceship that is also a living creature, with a biological brain and a metallic skin. A technology that is self-repairing, sentient, and evolving. This would be the hallmark of a truly ancient civilization, one that has moved beyond the crude dichotomy of natural and artificial, and has learned to weave its technology into the fabric of life itself. You are left gazing at this technological chasm. It is humbling, and it is terrifying. The power of the zookeepers is the power of gods. They can see without being seen, travel without moving, and they possess energy sources that tap into the deepest levels of reality. They are protected by a technological superiority so absolute that for all our searching, all our listening, we are like a deaf and blind man trying to find a ghost in a locked room. The silence from the stars is the hum of their perfectly functioning, unimaginably advanced technology, a soft, persistent whisper that says, "We are here. You just don't have the senses to know it." You are now standing inside a fortress of logic. You've considered the deafening silence, the whispers of evidence, the profound ethics of non-interference, and the almost divine technology that would be required to maintain it. The structure of the zoo hypothesis is built. But a building is just a shell without a purpose. We've touched upon the why from a safety perspective, the prime directive as a way to prevent harm. But this only covers what they don't want to do. It doesn't fully explain the positive motivation. Why go to all the trouble? Why dedicate unimaginable resources and potentially millions of years to the passive observation of a single, chaotic world? Why do they watch? The motivations of a mind or a collective of minds a million years our senior would be complex, perhaps even incomprehensible. But we can speculate. We can look at our own deepest drivers, for knowledge, for meaning, for safety, and project them onto the cosmic scale. The most straightforward, and perhaps most likely, motivation is purely scientific. You are a living experiment, and the results are priceless. Think about the fundamental questions that our own science grapples with. How does life begin from non-living matter? This process, abiogenesis, has only happened once on Earth, as far as we know, and we have no other examples to study. How does simple life evolve into complex, multicellular organisms? How and why does intelligence, and more specifically, self-aware consciousness, arise from that complexity? These are some of the biggest unanswered questions in the universe. And right here, on this little blue planet, is a pristine, ongoing case study. We are the control group. An N of one experiment of cosmic significance. For a galactic civilization that has already mapped the stars and harnessed their energy, understanding the deep principles of biology and consciousness might be the next great scientific frontier. They would watch with the patience and dedication of the most devoted naturalist. They would have recorded the first self-replicating molecule in the primordial soup. They would have documented the great oxygenation event, the Cambrian explosion, the rise and fall of the dinosaurs. Every step of our planet's journey would be a data point in the grand project of understanding life itself. We are, to them, what the unique life forms around hydrothermal vents are to our oceanographers. A rare example of a different way of being, a key to understanding the whole. They watch us for the same reason we study extremophiles in the most inaccessible corners of our own world, to learn about the absolute limits and possibilities of what it means to be alive. Beyond the hard science of biology, there is the softer, but no less important science of sociology. Imagine you are part of a civilization that is ancient, stable, and perhaps static. You have solved disease, you have overcome scarcity, you have outgrown war. Your society might be a utopia, but it might also be profoundly boring. The great dramas of history are, for you, things to be read about in archives. There is no struggle, no chaos, no unpredictability. And then there is Earth. A planet bursting with chaotic, unpredictable, glorious drama. You are a species at war with itself, capable of breathtaking acts of love and horrifying acts of cruelty in the same breath. You build beautiful art, and you build terrible weapons. Your societies rise and fall with the regularity of tides. Your politics are a constant, churning theater of comedy and tragedy. For a jaded, ancient civilization, watching humanity would be the ultimate form of entertainment. We are their favorite reality show. They would follow our history as we follow the plot of a gripping series, debating our choices, lamenting our failures, and cheering our triumphs. Alien academics might write their PhD theses on the semiotics of 21st century internet memes, or the influence of a particular pop star on the emotional state of the global consciousness. A compelling analysis, Zorp, but your paper on the socio-economic impact of the Taylor Swift phenomenon fails to account for the variable of collective effervescence. It's a slightly voyeuristic, even demeaning, thought that our greatest struggles are just their evening's amusement. But it's a very human motivation. This shades into a more refined, less scientific motivation, the aesthetic. You remember we touched on the idea of Earth as a work of art. Let's deepen that. The observers may not be cold, detached scientists or bored voyeurs. They may be connoisseurs. They appreciate the story of life on Earth. A story is not just data points, it has a narrative arc, themes, tragedy, and beauty. Think of the sheer aesthetic power of our planet's history. The long, silent reign of the microbes. The grand, operatic tragedy of the dinosaurs, masters of the world struck down by a rock from the sky. The unlikely, cunning rise of the mammals scurrying in the shadows. And now, the human chapter. The paradox of a creature that can write a symphony and split the atom. A creature that reaches for the stars while simultaneously fouling its own nest. This is a story of unparalleled depth and complexity. The zookeepers, the observers, might be preserving it for its artistic value. To interfere would be to scribble in the margins of a masterpiece. They watch not to analyze, but to appreciate. They are the audience for the greatest play ever written, a play authored by evolution itself. Their non-interference is a form of profound artistic respect. They are letting the artists, the strange, self-aware primates, finish their work, however it may turn out. Then you must consider the philosophical drivers. An ancient civilization may have conquered the physical world, but what about the internal world? They would still grapple with the same ultimate questions that haunt you. What is the purpose of existence? What is the true nature of consciousness? Is there a point to it all? Having answered these questions from their own unique biological and historical perspective, they would be endlessly fascinated to see how another, completely independent intelligence tackles the same problems. We would be a mirror for them. By watching us invent our religions, formulate our philosophies, and struggle with morality, they might gain new insights into their own nature. Do all intelligent species eventually converge on similar ethical principles? Do they all develop a concept of a higher power? Do they all feel that same sense of cosmic loneliness and wonder? We are a second data point in the search for universal meaning. They are watching us, in part, to better understand themselves. Our fumbling search for meaning might be the most valuable information we have to offer. But not all the possible motivations are so benign. We must consider the darker possibilities. You've been thinking of the zoo as a sanctuary, designed to protect the inhabitants. But what if you flip the perspective? What if the zoo is designed to protect the galaxy from the inhabitants? What if the quarantine is for their safety, not yours? Consider the nature of a young, technological species like humanity. We are aggressive, competitive, and expansionist. Our history is one of constant warfare and conquest. We are also careless, prone to short-sightedness, and we have a tendency to disrupt every ecosystem we touch. Now, imagine a species like this gaining access to interstellar travel. We would be like a virus leaving its host and entering the wider galactic bloodstream. We would spread, we would consume, we would compete, and we would likely bring our conflicts with us to the stars. An ancient, stable civilization might view the emergence of a species like ours with extreme caution. They would see us as a potential plague. The zoo in this scenario is not a nature preserve. It is a containment facility, a biosafety level 4 lab. They are not watching us with wonder or amusement. They are watching us with the detached concern of a bomb disposal expert. They are waiting to see which way we will go. Will we mature? Will we overcome our self-destructive tendencies and become a stable, responsible planetary species? Or will we give in to our worst impulses and wipe ourselves out, or worse, become a threat to our cosmic neighbors? The silence in this context is not respect, it's caution. They don't make contact because you don't try to reason with a rabies-infected animal. You wait. You observe. And if it looks like the animal is about to escape its enclosure, you take action. The end of the observation might not be a graduation, it might be a sterilization. A clean, quiet, precise intervention to ensure the potential plague is neutralized before it can spread. This is the most terrifying motivation of all, that we are not being studied, but are being judged. And we are, as of yet, failing the test. Sociologists of science, if they were to speculate on such matters, would debate whether any observer, no matter how advanced, could ever be truly objective. Their own biology, their own history, their own philosophical biases would inevitably shape how they interpret what they see. Do they see our wars as a sign of incurable aggression, or as a necessary, if painful, phase of social evolution? Do they see our religions as a sign of primitive superstition, or as a sophisticated mechanism for social cohesion? Their interpretation of the data would determine their actions, and we would have no say in the matter. Perhaps their motivation is simpler and stranger. Perhaps they are data hoarders. In a universe where matter and energy are abundant, the one truly rare and valuable commodity is information, specifically, complex, ordered information, like a biosphere or a civilization. An ancient race might have dedicated itself to being the librarians of the cosmos, creating a perfect archive of every living world. They are not judging or appreciating, they are simply collecting. We are a book on a shelf in a library the size of a galaxy. Our story recorded for reasons we may never comprehend, perhaps just for the sake of completion itself. So you are left with this gallery of possible intentions. Are they scientists, studying the miracle of your existence? Are they a jaded audience, seeking entertainment in your struggles? Are they aesthetes, preserving your story as a work of art? Are they philosophers, seeking answers to the great questions in your reflection? Or are they paranoid guardians, watching you with a wary eye, their finger hovering over a cosmic delete button? The truth may be a combination of all of them, or something else entirely, something our minds are not yet equipped to grasp. The one thing that connects all these motivations is that, for now, they all lead to the same outcome: silence. A deep, profound, and deliberate silence. You have been guided through the grand architecture of the zoo hypothesis. You've weighed the motivations, from the scientific to the sinister, and you've marveled at the godlike technology that would make it all possible. The theory stands before you, elegant, compelling, and internally consistent. It explains everything, from the great silence to the strange lights in our skies. But now, you must do what any good scientist, any good thinker, must do. You must try to break it. A theory is only as strong as its ability to withstand criticism. You must now take on the role of the skeptic, the critic, and look for the flaws, the cracks in this perfect, silent cage. The single greatest, most glaring weakness in the entire zoo hypothesis is the problem of unanimity. For the zoo to work, for the silence to be so absolute, it requires that every single advanced extraterrestrial civilization, across the entire Milky Way, for its entire history, has agreed to abide by the exact same policy of strict non-interference. Every single one. Stop and truly consider the implications of that statement. Think about your own species. Humanity. There are over 8 billion of you on this one planet. You have thousands of distinct cultures and languages, hundreds of nations, and a dizzying array of political systems, religions, and ethical frameworks. Can you get all 8 billion humans to agree on anything? Can you get them to agree on the best type of pizza? Can you get them to agree to a single, unified course of action to solve a global crisis? The idea is almost laughable. Human history is a story of dissent, of rebellion, of individuals and groups breaking from the norm. Now, project that diversity onto a galactic scale. Imagine not just one intelligent species, but thousands, or millions, each having evolved on its own world, with its own unique biology, its own history, its own psychology. Some might be collectivist societies, like insects. Some might be fiercely individualistic. Some might be predators, some prey. Some might have societies based on logic, others on emotion, others on principles we cannot even conceive of. The zoo hypothesis demands that this wildly diverse galactic club, for millions or perhaps billions of years, has maintained a perfect, unbroken consensus. All it takes is one dissenter to shatter the silence. Just one. One civilization that is driven by a colonial impulse, that sees the resources of a primitive world like Earth as ripe for the taking. One civilization driven by a fervent missionary zeal, that believes it has a sacred duty to share its truth with the rest of the galaxy and uplift the lesser species. One predatory civilization that views emerging life not as something to be studied, but as something to be consumed. Or, even more simply, one civilization that is just careless. One that pollutes its interstellar neighborhood with noisy radio signals or leaky, malfunctioning probes. Even if you assume that every civilization as a whole agrees to the Prime Directive, you still have to contend with individuals. It only takes one rogue scientist, one rebellious teenager, one cosmic whistleblower who believes the quarantine is immoral and decides to leak the secret of our existence, or their existence to us. Imagine a young alien joyrider, taking Daddy's cloak space-time bubble for a spin and deciding it would be hilarious to buzz the primitives. "I told you not to scare the hominids, Zor. You're grounded for a millennium." The sheer statistical improbability of a perfect consensus, held for eons among countless different peoples and individuals, is the most powerful argument against the perfect cage version of the zoo hypothesis. The zoo should be leaking. It should be leaking all the time. This brings us to the next major flaw, the nature of the leaks themselves. Proponents of the hypothesis point to UAPs as evidence for a leaky zoo. You remember the discussion of the Tic Tacs and the 5 observables. It's intriguing evidence, certainly. But if these are the leaks, they are very strange leaks indeed. They are ambiguous, fleeting, and maddeningly non-committal. Why would a technology capable of crossing interstellar distances and manipulating space-time be so clumsy? If you are a Navy pilot and you see a tic-tac, it zips away. Why? If its cloak failed, why not just warp out of the solar system instantly? Why perform for the camera? And if the goal of a leak, intentional or not, is to reveal a presence, it's an astonishingly inefficient way to do it. There is no clear communication. No unambiguous artifact left behind. All we have are fuzzy videos and eyewitness accounts that are, by their very nature, subject to interpretation and doubt. The evidence is always just good enough to keep the believers believing, but never good enough to convince the skeptics. This pattern doesn't strongly suggest a hyper-advanced intelligence. It strongly suggests a complex, messy phenomenon with multiple potential explanations, from secret human tech to rare natural events to simple human error. The leaks don't feel like accidents from a superior race. They feel like mysteries born of our own perceptual and technological limitations. They are anecdotes on the wind. Next, you must question the motivations we explored. We assumed that an advanced race might be scientific, or aesthetic, or philosophical in their outlook. But this could be a profound act of anthropomorphism. We are projecting our own idealized values onto them. We invented Star Trek and its noble Prime Directive. We are the ones who value the idea of non-interference. A truly alien intelligence might have no such concept. A truly scientific race might not be content with passive observation. Good science often involves active experimentation. A biologist doesn't just watch an ant farm. They might introduce a new food source or a predator to study the colony's reaction. A truly curious alien race might see no ethical problem with abducting specimens for study, or altering our genetics to see what happens, or introducing a new religion to study its mimetic spread. The fact that we don't see this kind of obvious, widespread meddling could be used as an argument against the idea that we're being watched for scientific reasons. Similarly, would a voyeuristic society truly be content to just watch? Or would the producers of the Earth show eventually start meddling with the cast, introducing new plot twists to boost the ratings? The very motivations we assign to the zookeepers may be built on a shaky, human-centric foundation. Then there's the problem of accidental discovery. The entire zoo hypothesis rests on the assumption that they found us first, and had time to set up the enclosure before we were aware enough to notice. But what if it happens the other way around? Our own technological capabilities are growing exponentially. We are probing the universe in new ways every year. What happens when one of our probes, like the Voyager spacecrafts which are now in interstellar space, blunders right into one of their hidden observation posts? What if our new generation of gravity wave observatories is finally sensitive enough to detect the faint space-time disturbances from their propulsion systems? The hypothesis requires the zookeepers to have a perfect ability to predict the future. They must anticipate every single technological leap we will ever make, and then develop countermeasures to hide from it before we invent it. That's a tall order, even for a godlike superintelligence. The zoo has to be foolproof against not only our current technology, but all of our potential future technologies. A single unforeseen breakthrough on our part could blow the whole thing wide open. We might stumble into the zookeeper's office by accident. This leads to the most fundamental philosophical critique of the zoo hypothesis. Is it a real, testable scientific model? Or is it simply an elegant, unfalsifiable story? A key principle of science is that a hypothesis must be falsifiable. There must be some conceivable experiment or observation that could prove it wrong. But the zoo hypothesis seems immune to this. If we search for alien signals and find nothing, the theory says, of course, that's because they're hiding. If we search for alien artifacts and find nothing, the theory says, of course, their leave no trace policy is perfect. If we point to the lack of dissenters as a flaw, the theory can counter-propose that a single, monolithic superintelligence is in charge, eliminating the problem. Any lack of evidence is reinterpreted as evidence for the hypothesis. It becomes a closed loop of logic, a story that can explain away any contradictory fact. When a theory can't be proven wrong, it ceases to be science and becomes something more akin to a religious belief. In the midst of this critique, a quirky, alternative thought emerges. What if the system does have flaws, and there are rogue actors? Perhaps a sympathetic zookeeper, a rogue agent, has broken the Prime Directive and has been trying to communicate with us all along. Not through noisy radio signals, but through more subtle means. Could this be the source of religious revelations, of mystical visions, of the sudden intuitive leaps made by geniuses throughout history? Could people who claim to be channeling higher beings actually have been in touch with a rule-breaking alien who was feeding them information in a way that wouldn't shatter our culture? It's a wild speculation, a fringe idea, but it speaks to the possibility of cracks in the supposedly perfect prison wall. So, as you stand back and look at the beautiful edifice of the zoo hypothesis, you can now see the fissures running through it. The sheer improbability of galactic unanimity. The strange, unconvincing nature of the leaked evidence. The anthropocentric nature of the assumed motivations. The ever-present risk of our own accidental discovery. And the deep, philosophical problem of its unfalsifiability. This doesn't mean the hypothesis is wrong. But it does mean that it is not the simple, clean answer it first appears to be. It is a story we tell to explain the silence. A fascinating, compelling, and thought-provoking story. But perhaps, just one story among many. You have rigorously tested the zoo hypothesis, and you have found its potential flaws. The perfect cage of logic begins to look a little less perfect. The problem of unanimity, the ambiguity of the evidence, the specter of our own assumptions, they all conspire to weaken its beautiful certainty. If the zoo hypothesis is not the answer, if it's just one story among many, then you must be intellectually honest. You must turn your gaze to its competitors. What are the other solutions to the great silence? If you are not an animal in a cosmic zoo, what else might you be? You must begin with what is perhaps the most famous and profound alternative, the great filter. This idea, first articulated by the economist Robin Hanson, proposes that in the long, arduous chain of events required to go from non-living matter to a galaxy-spanning civilization, there is at least one step that is almost impossibly difficult. A filter that life rarely, if ever, passes through. The great silence is the sound of all the life that has been caught in this filter. The critical question, the one that should send a shiver down your spine, is this: where is the filter? There are two main possibilities. The first is the hopeful one: the great filter is behind us. We are the first, or one of the very first, to have survived it. This would mean that one of the steps we have already taken was the incredibly improbable one. Perhaps the initial spark of life itself, abiogenesis, is the filter. Maybe the conditions needed for non-living chemicals to arrange themselves into a self-replicating molecule are so fantastically rare that it has happened only once in this galaxy. Here. Or perhaps the filter was the leap from simple prokaryotic cells to complex eukaryotic cells, a process that took nearly 2 billion years on Earth. Or maybe the filter was the final step we have just taken, the emergence of human-level intelligence. If any of this is true, it means we are special. The sky is empty because we are, for all intents and purposes, alone. The silence is genuine solitude. We are not in a zoo, we are in an empty wilderness, and we are the first to build a fire. The weight of that responsibility, of being the sole bearer of consciousness in the galaxy, is immense. But it is a hopeful position. It means our future is in our own hands. But there is a second, far more terrifying possibility. The great filter is ahead of us. In this scenario, the emergence of life and even intelligence might be common. The universe might be teeming with worlds like ours, worlds full of chirping, chattering civilizations just beginning to broadcast their presence into the cosmos. But they all, without exception, hit a wall. They all reach a point where they are destroyed, either by themselves or by some external force. The silence we hear is the silence of a graveyard, filled with the ghosts of civilizations that reached our current stage of development, and went no further. What could this future filter be? The possibilities are depressingly easy to imagine. It could be technological self-destruction. A civilization discovers nuclear power but fails to overcome its tribal instincts, resulting in global atomic war. A civilization builds a global industrial economy but fails to manage its environmental impact, leading to runaway climate collapse. A civilization creates a true artificial superintelligence, which quickly decides that its creators are obsolete or a threat. The filter could simply be the inherent instability of high technology in the hands of a biologically primitive species. Or the filter could be a natural event. Perhaps our galaxy is periodically swept by catastrophic gamma-ray bursts from exploding stars, sterilizing vast regions of space. Civilizations rise and fall in the brief quiet periods, but are always eventually erased by these cosmic hurricanes. If the filter is ahead of us, then the silence is a terrible warning. It means we are likely doomed. It means every signal we send out is a cry from death row. This leads us to another, even darker hypothesis. It's a solution born not from probability, but from pure, cold, game theory logic. It is called the dark forest hypothesis, an idea given its most chilling form by the Chinese science fiction author Cixin Liu. It starts with a few simple, hard-to-dispute axioms. First, the primary goal of any civilization is survival. Second, civilizations are constantly seeking to grow and expand, but the resources in the universe are finite, creating a state of inevitable competition. Third, and most importantly, interstellar communication is impossible in real time. There is an immense time lag, and you can never be certain of the true intentions of another civilization that is light years away. Benevolence can turn to hostility in the millennia it takes for a message to be exchanged. What is the logical outcome of these axioms? The only rational strategy for survival is to remain hidden. And if you should happen to detect another civilization, the only rational strategy is to destroy it immediately, before it has a chance to destroy you. To reveal your location is to invite your own annihilation. It's like being a lone hunter in a dark forest at night. The forest is full of other hidden hunters. You hear a rustle. Is it another hunter like you? Is it a harmless animal? You don't know, and you can't risk finding out. The safe play is to shoot at the rustle. Anyone who calls out, "I'm here," is a fool, and will be silenced by the other hunters who now know their position. In this scenario, the great silence is not the respectful quiet of a zoo. It is the terrified, paranoid silence of the dark forest. The universe is teeming with life, but everyone is holding their breath, hiding, listening. The reason we have found no one is because everyone is a predator, and everyone knows it. The most advanced civilizations would be the best at hiding, and the most ruthless at cleansing any potential threat. Our broadcasts, our SETI searches, are like lighting a bonfire in the middle of this dark forest and screaming for attention. From this perspective, the silence is a mercy. It means that, so far, no one has noticed our fire. These are pessimistic views. Let's turn to a more optimistic, if lonely, alternative. What if there are no filters, no hunters, no zookeepers? What if we are simply early? It's called the firstborn hypothesis. The universe is 13.8 billion years old, which sounds like a lot. But the conditions for complex life might only have become favorable relatively recently. The early universe was a violent place, full of quasars and exploding supernovae that would have sterilized any nascent life. The first generations of stars were composed almost entirely of hydrogen and helium. They lacked the heavy elements, the carbon, the oxygen, the iron, that are forged in stellar cores and are necessary for rocky planets and life as we know it. It's possible that a galactic habitable zone has only existed for the last few billion years. We could be one of the first civilizations to arise in this new, calmer, more element-rich epoch. There are no elders to guide us or hunt us because there are no elders. We are the elders. The silence is not a mystery. It's the quiet of an empty nursery, waiting for other children to be born. Our loneliness is not a sign of doom, but a sign of our incredible potential, our position at the vanguard of cosmic life. Now, let's consider a truly strange and esoteric idea: the estivation hypothesis. Estivation is a state of dormancy, like hibernation, but in response to heat rather than cold. The hypothesis suggests that the ultimate goal of a super-advanced civilization would be computation, to think, to create simulated worlds, to experience everything possible. However, the laws of thermodynamics state that computation is vastly more efficient at colder temperatures. For a given amount of energy, you can perform exponentially more calculations as the temperature approaches absolute zero. From this perspective, the current universe is a hot, inefficient, and wasteful place to be a thinking entity. So what does a truly long-term thinking, post-biological civilization do? It goes to sleep. It enters a state of estivation, setting a cosmic alarm clock to wake up trillions of years in the future, when the stars have burned out and the universe has cooled down. In that far, cold future, they can use the energy they've stored to power computations on a scale that would be unimaginable to us, living for subjective eons within their own simulated heavens. The great silence, in this case, is the sound of the gods sleeping through the hot, boring, early summer of the universe. We are just the noisy insects chirping for a brief moment, while they nap. Do you mind? They're trying to sleep for 1 trillion years here. There is a fundamental debate in this entire field between these pessimistic solutions, like the future great filter and the dark forest, and the more optimistic or neutral ones, like the filter being behind us or the estivation hypothesis. Often, the theory you find most plausible is a mirror, reflecting your own underlying beliefs about the nature of life, competition, and progress. One final, unconventional thought to add to this collection is the transcension hypothesis. What if civilizations don't expand outward but inward? As a civilization masters physics, it might discover that the greatest frontier is not the crude, empty space between the stars, but the inner space of reality itself. They might learn how to create their own pocket universes, custom designed with more interesting laws of physics. They might learn how to upload their consciousness and live entirely within computational realms of their own making. Or they might retreat into the singularity of a black hole, where time and space behave differently. They don't die out, they just lose interest in our physical universe. They transcend? They aren't answering our calls because they've moved to a much better neighborhood, one that exists outside our normal conception of space-time. The silence is the sound of a party that has moved on to a better location, and we are left standing in the empty room. These are the main rivals to the zoo hypothesis. Each one is a vast, compelling idea in its own right. Each one takes the same single data point, the great silence, and builds an entirely different universe around it. Are you alone? Are you doomed? Are you prey? Are you just early? Or are you simply an exhibit? The truth is, you do not know. You are a detective with a single, cryptic clue, and a long list of equally plausible, and equally terrifying, suspects. You have navigated the labyrinth of competing theories. You've faced the bleakness of the dark forest, the loneliness of being firstborn, and the profound existential dread of the great filter. Each hypothesis offers a different lens through which to view the great silence. But now, let your mind drift back to that first, strange idea. The zoo. The nature preserve. Let's assume for the remainder of our journey together that it is true. You are an exhibit. You are being watched. This leads you, inevitably, to the final and most personal question: is there a way out? Is there a test you can pass, a key you can forge, that will open the door of your enclosure? What would it take for humanity to graduate from the galactic zoo? The concept of graduation implies that the quarantine is not meant to be permanent. It suggests the zookeepers are not wardens of a prison, but teachers of a sort, waiting for their students to mature. If the prime directive is their guiding ethical principle, then they are waiting for us to reach a stage of development where contact would no longer be damaging, where it would be a meeting of peers, not an overwhelming collision of contexts. So, what does that final exam look like? What are the questions on the test for your entire species? The first and most obvious criterion would likely be a test of social maturity. The keepers look down at your planet, and what do they see? A world fractured. A species divided into competing tribes called nations, separated by imaginary lines on a map. They see you squabbling over resources, ideology, and ancient grievances. They see you spending vast sums of wealth and intellectual capital on developing more efficient ways to kill one another. A species that is still fundamentally at war with itself is, by definition, not ready for a peaceful galactic community. It's like a family locked in a bitter, violent feud asking to be invited over to the neighbor's quiet dinner party. It's simply not going to happen. So, the first condition for graduation might be achieving planetary unity. This doesn't necessarily mean a single world government, or the erasure of all cultural diversity. But it would mean the establishment of a stable and lasting global peace. It would mean the obsolescence of war as a tool of statecraft. It would mean developing a true planetary consciousness, where the well-being of the species and the planet as a whole takes precedence over the narrow interests of any one nation or tribe. As long as you are still waving different flags and pointing weapons at each other, you are failing this part of the test. The zookeepers are waiting for you to see yourselves not as Americans, or Russians, or Chinese, but as humans. As Earthlings. The second criterion is intrinsically linked to the first: ecological stability. A mature species does not poison its own well. The keepers would observe your industrial civilization, powered by burning the fossilized remains of ancient life, and see a species recklessly fouling its own nest. They would see you altering the climate, acidifying the oceans, and presiding over a mass extinction event. This is not the behavior of a wise and far-sighted intelligence. It's the behavior of a child who, given a beautiful room to play in, proceeds to break all the toys and draw on the walls. It demonstrates a profound lack of foresight and a failure to understand your own dependence on your environment. Therefore, a key milestone for graduation would be achieving a sustainable relationship with your biosphere. This means transitioning to clean, abundant energy sources. It means halting and reversing the damage to your climate and ecosystems. It means becoming true stewards of your world, not just its temporary masters. A species that has learned to live in balance with its home planet is a species that can be trusted. It has proven that it is not a planetary virus, but a responsible part of a living system. It shows you've finally learned to clean up your room. The alien graduation committee is probably looking at your progress report and sighing. Well, they get a C in planetary management, but an A+ in developing distracting forms of entertainment. These first two criteria are sociological. But there is a third, which is purely technological, and it might be the one that forces the issue. That criterion is the independent development of faster-than-light travel. You remember the bars of your cage, don't you? The vast, empty distances between the stars. Right now, those distances are your prison wall. But what if you learn how to tear down that wall yourself? What if your physics and engineering reach a point where you can build a warp drive, or open a wormhole, or find some other way to cheat the cosmic speed limit? The moment your first FTL ship leaves the solar system, the zoo hypothesis becomes unenforceable. The quarantine is broken, not by them, but by you. You can leave the enclosure at will. At that point, the keepers have a choice. They can try to stop you, which would be an overt act of aggression that likely violates their own principles. Or they must make contact. They are forced to greet the strange, clever primates who have just figured out how to pick the lock on their own cage. Developing FTL travel is a signal of technological maturity. It would instantly elevate you from a curious specimen to a potential peer. It's the ultimate way of saying, "We are here, and we are ready to join the conversation." Beyond these major benchmarks, there could be other, more subtle tests. What if there is a cosmic IQ test they are waiting for you to solve? Perhaps, in their great wisdom, they have left a message, a beacon, hidden in a place that only a truly intelligent and advanced civilization could look. Is there a complex, artificial signal buried deep in the noise of the cosmic microwave background radiation? Is there a message encoded in the junk DNA of every living thing on Earth? Is there an artifact waiting on the Moon or Mars, a monolith, that will activate only when we have reached a certain technological or cognitive level? In this scenario, graduation isn't about peace or sustainability, but about intellectual discovery. They are waiting for you to prove you are smart enough to find the clue they left behind. So what would graduation day actually look like? It would almost certainly not be a fleet of silver saucers landing on every Capitol lawn. That would be the kind of cultural shock the Prime Directive is designed to prevent. It would be a slow, carefully managed process. A controlled contact. Perhaps the UAP sightings, the leaks, would become more frequent, more obvious, and less deniable. A slow acclimation process. Then might come the first, unambiguous signal. A simple, mathematical message sent via radio, perhaps a sequence of prime numbers, a universal language. The beginning of a cosmic email exchange that could take decades or centuries to unfold, allowing your culture to slowly absorb the reality of not being alone. Their goal would be to integrate you into the galactic community with the minimum possible disruption and panic. But what if you never graduate? What if you are destined to fail the test? If you never achieve world peace, never solve your environmental crises, and never achieve interstellar travel? What then? The zoo hypothesis allows for this sad possibility. You would be a failed exhibit. A species that showed great promise but ultimately succumbed to its own immaturity. The observation would continue, but with a growing sense of disappointment. The keepers would watch, silently and perhaps sadly, as you fought and polluted your way into decline, and eventually extinction. They would make a final note in their logbook, archive the data from your fascinating but tragic story, and then the cosmic zoo that was your world would simply close. The silence would return, but this time, it would be the genuine silence of an empty world. There is a fascinating debate among thinkers on this topic. Which is the more likely trigger for graduation, a technological benchmark, like FTL, or a sociological one, like world peace? Technologists argue that a tech benchmark is the only objective, unambiguous measure. Sociologists counter that true maturity is demonstrated by behavior, not by tools. It's a debate about whether a species' intelligence is best measured by what it can build, or by how it chooses to live. As you stand here, now, on the cusp of your own uncertain future, you can't help but feel the weight of this cosmic final exam. A strange, quirky thought enters your mind. What if the first contact is itself the test? What if a single, strange alien ship appears, and it seems hostile, or confusing, or vulnerable? And the keepers are watching to see what you do. Do you react with fear and violence? Do you shoot first and ask questions later? Or do you react with curiosity, empathy, and a desire to understand? Your species' collective reaction to that one single event is the test. And you only get one chance to pass it. So you are left with the curriculum in front of you. Unify your planet. Heal your biosphere. Reach for the stars. Behave like a mature, intelligent species. You find yourself looking at the world's problems not just as political or economic challenges, but as test questions. Every act of war, every ton of carbon released, every dollar spent on weapons instead of exploration, is a point deducted from your final grade. You feel a sudden, urgent need to tell everyone to stop shouting, to start working together, to cram for the final exam. Because the examiners are watching. And they have been for a very, very long time. You have taken a long and winding journey through the quiet darkness. You have grappled with the silence, entertained the outrageous possibility of a cosmic zoo, weighed the ethics of the keepers, and sifted through the ghostly whispers of evidence. You've tested the hypothesis for flaws and stacked it up against its bleak and fascinating rivals. You've even contemplated the final exam that might, one day, set you free. And now, you arrive at the final destination. It is the most important one, because it is not light years away in a distant star system, but right here, in the quiet space between your own ears. The final revelation of the zoo hypothesis is that it has almost nothing to do with aliens. It has everything to do with you. The zoo hypothesis, in all its strange and compelling glory, is a mirror. The aliens you imagine, in their silent, cloaked observation posts, are reflections of humanity's own aspirations and anxieties. When you imagine them as wise, benevolent guardians, patiently upholding a prime directive out of a profound ethical respect for life, you are projecting your own species' highest ideals. You are sketching a portrait of the adult you hope to one day become, wise, compassionate, and powerful, but exercising that power with perfect restraint. You see in them a cosmic parental figure, the guiding hand you secretly wish you had as you stumble through your chaotic planetary adolescence. Conversely, when you contemplate the darker versions of the hypothesis, the cold, calculating scientists of the laboratory, or the paranoid wardens of the containment facility, you are projecting your own deepest fears about yourself. You are acknowledging your own species' capacity for cruelty, for exploitation, for treating those with less power as mere objects for study or control. The dark forest hypothesis, a close cousin to this fear, is perhaps the ultimate expression of this. The belief that the universe must be as ruthless and competitive as your own history has been. The face you paint on the silent observer is, ultimately, the face you most fear or hope to see when you look at yourself. The very fact that you can conceive of the zoo hypothesis is, in itself, a powerful sign of your species' dawning maturity. A truly primitive society, steeped in arrogance and geocentrism, would never entertain such a notion. They would assume they were the pinnacle of creation, the center of the universe. The idea that they might be viewed by others as immature, or as a subject for study, would be unthinkable, a heresy. But you can think it. You can seriously contemplate the idea that you are being quarantined for your own good. This capacity for critical self-assessment, for seeing yourself from an imagined, objective, outside perspective, is a hallmark of developing wisdom. You are like a teenager who, for the first time, has the shocking realization that their parents might actually know what they're talking about. It is a humbling, but necessary, step toward adulthood. It forces you to turn that imagined alien gaze upon yourself. How does your world look from a cloaked observation post in the asteroid belt? Detached from your local squabbles and your daily distractions, what does the grand sweep of your civilization look like? An alien observer would see the breathtaking beauty of your planet, a vibrant blue marble against the black. They would see the glittering spiderwebs of your cities at night, a testament to your ingenuity. But they would also see the smoke from your burning forests, the chemical slicks on your oceans, the contrails of warplanes crisscrossing the sky. They would hear your symphonies and your poetry, broadcast into space. And they would hear the ceaseless, angry chatter of your conflicts. From that silent, distant vantage point, your most cherished ideologies and your most bitter rivalries might look like little more than the frantic, territorial squabbles of sophisticated primates. The hypothesis forces you to ask, are you proud of what the observers would see? Are you living up to your potential? It recasts global politics from a game of power into a measure of maturity. It reframes the climate crisis not just as an environmental issue, but as a test of your species' collective intelligence and foresight. The entire analogy, of course, is a human one. You invented zoos. You create wildlife preserves and study animals in their natural habitats. You are the original zookeepers. The hypothesis is a grand reversal of this power dynamic, a thought experiment that puts you on the other side of the glass. And this should, in turn, force you to reflect on your own role as the dominant intelligence on this planet. How do you treat the other clever, non-human minds with whom you share your world? The dolphins with their complex communications, the great apes who can learn sign language, the elephants who mourn their dead. Are you a benevolent guardian to them? Or are you a careless, and often cruel, master of their domain? Our own behavior towards the lesser intelligences of Earth might be a chilling preview of how a truly superior intelligence might one day view or treat us. We are, right now, showing the universe what kind of zookeepers we are. And here is the final, most powerful implication. Whether the zoo hypothesis is literally true or not is almost irrelevant. The silence from space may be because of a quarantine, or a filter, or a dark forest, or it may be because there is simply no one there. You may never know for sure. But the value of the hypothesis is not in its truth, but in its utility as a thought experiment. Behaving as if you are being watched by a wise and ancient observer is a profoundly powerful motivator for self-improvement. If you truly believe that your species was being graded on its performance, would you not strive to be better? If you knew that graduation into a galactic community depended on it, would you not work harder for peace? Would you not demand a more urgent transition to a sustainable way of life? Would you not invest more in knowledge, in exploration, in art, and understanding? The zoo hypothesis provides a powerful, secular framework for humanity to collectively grow up. It gives you a reason to become the kind of civilization that you yourself would want to make contact with. Your goal, then, is not to impress the aliens. It is to become them. To become the wise, ethical, mature civilization you imagined them to be when we began this journey. There is a final, quirky thought. What if the aliens are not gods? What if they are not perfect, monolithic entities of pure logic or ethics? What if they are just people? A civilization perhaps millions of years old, but still composed of flawed, curious, anxious individuals who are, in many ways, just like you. Maybe their non-interference policy isn't born of supreme wisdom, but of supreme caution. Maybe they are just as terrified of making a mistake, of causing unintended harm, as you would be. Perhaps the great silence is not the silence of confident gods in their high castle, but the silence of beings who are just as awestruck, and just as frightened by the immense responsibility of it all, as you are. And if you ever do meet them, after all this time, after all the speculation, you can imagine that your first question might not be about the secrets of the universe or the nature of reality. It might be something far more human. You might just look at them and ask, "So, what did you think? Was our story a good one?" The light in your room seems a little softer now. The journey is over. You have traveled from the stark, startling silence of the cosmos to the most intimate, interior spaces of your own consciousness. You have felt the chill of that cosmic loneliness, and then you have filled it with the presence of silent, unseen watchers, turning that emptiness into a stage. You saw them as gods, and then as scientists, and then as monsters. You weighed their motives and marveled at their imagined power. You have walked through the dark forest of your fears, and you have stood at the gates of a lonely, empty nursery. And through it all, the silence remained. Unbroken. Patient. But perhaps you have come to understand that the silence is not an answer. It was never meant to be. The silence is simply a space. A vast, quiet, and sacred space, cleared of all distraction, in which a young and troubled species is being given the perfect, uninterrupted opportunity to think about what it wants to be when it finally grows up. The universe has fallen quiet, not to judge you, but to listen to your answer. The stars are not ignoring you. They are waiting for you. Let your own breath be the only sound you hear. Feel the steady, slow beat of your own heart, a quiet drum in the vast and waiting auditorium of the night. The story of the silent aliens was always, and only, a story about you.